Hello everyone, this is Sightem, and in today's video I'm going to be showing you how to reverse engineer Assault Cube's do damage function using ID and Cheat Engine, and at the end I'm going to be showing you how to make a one-hit kill hack. Everything you need to follow this video will be attached in the description. So, how do we even approach finding the do damage function in Assault Cube? Well, we can find an entity, find its health, add it to Cheat Engine, and see what accesses its address when we damage the entity. So, let's go to reclass. Let's look at the entity list. I've found my entity already, and I'm going to take its health, and I'm going to paste it into Cheat Engine. There. Ignore that. To find out what accesses its address, and damage the entity. The subtraction instruction shows up, which is good. And I'm going to take its address. I'm going to switch back to ID. I'm going to press G, paste it in, and I'm going to go to its address. Press F5 to get the pseudocode, and sync it with ID view A. So, with everything in game hacking, you want to first form an assumption, take it at face value, test it, and see if you're correct. So, I'm going to assume that A2 plus 4, whatever this A2 is probably our health, and A3 is probably our damage. Now, A2 is very easy to verify. Let's actually go here. We're actually right here. So, I'm going to toggle breakpoint. I'm going to go back to Assault Cube. I'm going to damage the entity. This video is sponsored by Malcore.io. As reverse engineers, we know how critical it is to thoroughly analyze files for potential threats and vulnerabilities. Traditional sandbox solutions can be frustratingly slow, taking several minutes to scan a single file. That's where Malcore comes in. Malcore is an advanced, next-generation sandbox solution built for speed and scale. While other leading tools can take several minutes to analyze a single file, Malcore delivers results in just seconds. Some of Malcore's standout features include advanced static and dynamic analysis, shellcode emulation to unpack obfuscated malware, similarity matching to identify related malware variants, fuzzy hashing or SSD for similarity analysis, dynamic Windows OS emulation, and many, many more. By emulating the target environment directly, Malcore can sandbox files without needing to spin up full virtual machines every time. This method enables Malcore to analyze malware with unparalleled speeds and capture low-level details other solutions simply miss. They also offer an extensive API that allows you to integrate Malcore into your existing security stack. This makes it easy to automate your analysis workflows and scale your security operations. Want to see Malcore in action? Sign up for a free trial over at malcore.io. So, you can see that EVX is 0330cc, F7, whatever. If we go back here, we can see 0cc F7. So it's in the same address range. Now let's see where this is. 884 right here. So A2 is pointing to something before our health. So we can actually rename this to pointer to before health. Sure. We also said that A3 is probably our damage, right? So I'm going to rename this to damage maybe. This damage maybe is coming from another function. It's being passed into this function as an argument. So I'm going to go back to Cheat Engine and I'm going to do stack trace. I'm going back one frame, right here. I'm going to do go to address, take this address, go back to ID, press G, jump to address, and we are here. This is our damage maybe variable. Again, this function is also taking it as an argument. So this is also probably not what we want. But what's interesting here is that it says v6 plus 61. If we go to ID view, this is actually indexing to ESI plus F4. If we go back to reclass, this is exactly what we see. So that's our offset F4, that's our health. So ESI is probably our damaged entity, right? Let's actually test this. I'm going to take this address. I'm going to go back to Cheat Engine, Control G, paste, and I'm going to toggle breakpoint. Hit run, go back to Assault Cube, damage the entity, and see what ESI is all about. ESI is 0cc F7, whatever. 0cc F7, 790. Yep, exactly. So this is pointing to our damaged entity. So let's rename v6 to damaged entity. Why not? And we can go ahead and rename A2 to damage maybe, because it's not coming from this function. So we're going to go back to cheat engine and do stack trace, go back one step right here. Take the address, paste it into IDA, and see what's going on. Okay, so we see more or less the same thing. This A2 is our damage maybe, which is being passed into this function, and it's not being modified at any point, right? So again, let's rename this to damage maybe. Whoops. Nice one. And go back one more step and see where this is coming from. I believe you'd go here. Yep. Take the address, paste it into IDA, and we are here. Let's go here. So this is calling our function, I believe. Yep, damage maybe. Press F5 again. And then we can jump back to the address again. F5. Yeah. So this is our damage maybe, I believe. Damage maybe. Let's rename this to damage maybe. Again, so this is just another function that's calling our function, right? It's not modifying this argument at any point, right? So we're going to go back here to where we jumped, and we can see that damage maybe is v5. Whenever you see v, it means that it's a local variable, right? So I'm going to rename this to damage, because this is probably our damage and it's probably what we're looking for. So let's actually see where this is coming from. Press X, go back here, and let's reverse from top to bottom. Okay, so I'm going to take this address, pop it into cheat engine again, and set a breakpoint. I want to see what V3 and A3 and these are all about, right? So let's hit run a bunch of times, hit our entity, and we can see that V3 is being set to this. This is actually this instruction. ESI should already be set. This is the mov SX. This is our move. ESI is 0DFA. Okay, so this is our damaged entity. Let's see. What if it's the player pointer? Yep, 00DFA. Yep, this seems like this is our player entity. So maybe this is our damager. So this is like, so V3 is gonna be, I guess, pointer to, or I guess copy of damage dealer pointer, and an A3 is going to be damage dealer pointer. Damage dealer, or I guess pointer to damage dealer, right? What's V4? Let's see. V4 is ESI plus 374. That's being moved into EAX. 374 should be familiar for you because it's the current gun offset. So V4 is our, or I guess, damage dealer gun. Pointer to damage dealer gun. Yep. So damage is being set here, right? It's offsetting into pointer to damage dealer gun. So meaning here, right? And it's going to offset, let's see, 0C. This is our gun info class. It's going here, and we actually don't have enough bytes to see what's going on. 268, so I'm going to add a bunch of bytes here to see what's going on. Turn this 268 to hex, and at offset 10C, we see that it's being moved into our damage as an int16. So in the reclass, we can change this to an int16 and call this damage. Whoops, damage. Change to an int16 too, because it's probably an int16. We don't know what this is, but it's not relevant to us. So And then we see V6. This is pointer to damage dealer gun plus 4. So go back here. This is our gun ID, right? So, and it's being set, it's a comparison to 3. So if it's 3, okay, B gun ID if 3, I'm gonna call it. Weird name, doesn't matter to us. Let's go back to our damage, because this is what we're here for. We can see 3 extras. This is the first one. We can see it right here. 1 here, and 1 here where it's being passed into our function, right? So what's this? What is this all about? This is V39. So let's see, what's V39 exactly? So go back here. So 374. That's our pointer to player pointer to damage dealer 221, right here, plus 4. So that's our gun ID, right? Yeah. So I'm going to rename this to gun ID, whatever you want to call it, right? And then we go into this if statement. If it's not 0, if it's not 5, okay, or the damage dealer isn't our entity, this 50 F4F4, or if it's not 2, or it's V48 isn't 2, excuse me. So what is V48 coming from? V48 is being calculated in this huge routine, so we're going to ignore it for now. We're going to see what significance 5 has to gun ID. As it turns out, gun ID 5 is our sniper, right? If I go back to reclass, that's our gun ID. So gun ID 5 is associated to our sniper. Okay, so let's see what V48 is. Let's try to figure that out by just trial and error. Let's see. I'm going to take that and I'm going to paste it into cheat engine. But before we do anything, let's actually think for a second, right? So if V48 isn't 2, we jump this entirely and go to here where we put in the damage, right? But if it is 2, we don't jump and we do this, right? Okay, why would you want to multiply damage by 3? Well, maybe it's a headshot multiplier. That's something we can easily test for. I've already breakpointed this instruction, and I'm going to go back to assault cube, and I'm going to damage my entity. So we can see that if it's a headshot, it does indeed get hit. And if I click run and damage it again, it doesn't get hit, right? So our assumption that this is a headshot multiplier is probably correct. Now, what if we wanted to register a headshot, or we'll do this multiplication by 3, but we don't want to hit a headshot? Well, we can probably just knob out this comparison, right? So let's test it out. I'm going to knob this out, and I'm going to knob this out. Let's go back to our game. Back here. Shoot the foot. Run. Headshot. Okay. So this is probably correct. Right. Yep. So we just made always headshot with our sniper. The reason it only works on our sniper is because of this gun ID comparison to 5. Right. So what if we always wanted to do headshot damage, but with any gun? So we could probably do the same thing. We could probably just knob this out and knob this out. Go back to our game, go here, set a breakpoint here, find our entity, damage it, and we can see that this instruction does get hit. Run, toggle breakpoint. I just two-shot the entity with a pistol. So this is probably correct. This is probably what we want. So, if we go back here to our game, let me just restore these. Go back here to the very top of our function. This value, this 100 and C in our gun info structure, in reclass is we assume that it's our damage, right? So let's see. Let's set it to some crazy value, like 1,000. And let's see if our gun, or rather our pistol, actually one-shots the entity. Okay, let's see. It does. We just one-shotted the entity with a pistol. So this is where our damage comes from, and this is how damage is actually calculated based on where you hit the player, probably. You can sit here and like reverse this if you want. I don't think it provides anything of value, but hey, you do you. So now I'm going to show you how to incorporate this into our proof of concept external. All right, let's go. So first thing I'm going to do is I'm going to do a get async key state, and I'm going to do vk numpad 4 because the previous one is 3. Right, and with 1, do that, and then I'm going to do b one shot is equal to b one shot. I'm going to do if b one shot oops, have this, and if it's false, come here, do this. I'm going to take this, and I'm going to introduce a new boolean right here. Go back down here, and now these are going to be our knobs, and these are going to be our patches, right? Our knobs are going to be these bytes. So this comparison, and then we skip a comparison. That's our local pair comparison. And this comparison. So that's a comparison. That's a gun ID comparison. And that's the headshot comparison, I believe. Not the Leah. This. Right, so copy this. Alright, so the first knob is going to be, I think, 5 bytes. Yes. Yep, 5 bytes. So we're going to do module base plus this address right here. Pass this whole thing to a byte pointer, obviously. Byte pointer. Go back here. We're going to give it the size of 5, and we are going to do hprocess. Right, and we're going to be doing another knob right here. Instead of this, we're going to do this, and then do 7, and that should be fine. Now, onto our patches. We basically want to do mem patch and restore all the bytes we just knocked out. Cast the byte pointer, same thing as the knob. And then we're going to do, let's see, we're going to do these bytes, right? So paste these in for now, and then 75 and 18. That's just faster. Now I'm going to do control, and actually no. It's a little trick for you that you can use. You can do aux, and there you go. And then I'm going to do the same thing again. Get rid of all the spaces, and that's it. There you go. And I'm going to do byte pointer again. Right. Yep. If I can cast properly. Nice one. And then I'm going to do 5 and h process. And then for the other patch, we're going to do basically the same thing with different bytes and size and address, obviously. Right, and change the size to 7, and h process is the same. Okay, now if we run our hack, we should see the always headshot hack work, hopefully. Do numpad 4, go back to assault cube, and let's see. Headshot, headshot, nice, and then this should 2-shot, hopefully. 2, it does. Okay, now let's go back and make it one step better. I'm going to make every gun one shot by modifying its damage. We found the damage in the video at offset 10C of the gun info struct, right? So the first thing I'm going to do is I'm going to use uint pointer t, current gun pointer, and I'm going to do find DMA addy. If I can type, yep, do h process. And then we're going to go from the local player pointer to offset 374. And we're going to do a dereference to get our current gun, right? So we're gonna do 374 and 0, right? And now I'm gonna do, that's unint pointer, okay. Now I'm gonna do a uint pointer t again, and gun info. We're gonna see why we're doing this in a second. And I'm gonna do read process memory because we don't need to do find DMA ADI again. It's kind of costly, so we're gonna avoid that. We're gonna do read process memory. We're gonna do h process, and we're gonna do, wait, where is this? So it's at offset 0c. So we're gonna do current gun pointer plus 0x0c, or 0xc if you want to. Cast this to a void pointer so that the compiler doesn't complain. We're gonna do, let's see, gun info, size of, just do, and we're gonna do null pointer. Now that we have our gun info class, we have the address of it, right? We're gonna go in one shot, and we are going to do a write process memory to its address. We're gonna do one to its address, you'll see. Right, so what we've done here is that we are offsetting into the gun info class at offset 10c and setting this to a new value, which is 1337, right? This value has the size of an int16. So we're passing a write process memory the size of int16t, and we are passing null pointer as the last parameter, right? Standard. Now, you want to restore the damage of the gun you've overwritten, right? But to overwrite it again, you're gonna need to know the initial, like the original damage of that gun, right? But currently, we are not storing that value in any bay. So what can you do? Well, we can, through trial and error, find out every gun and its ID and its damage, right? And we could map the ID of a gun to its damage, right? That's a naive approach. But as it turns out, Assault Cube uses 1 through 6 for its gun IDs, right? So 1 is pistol, 2 is carbine, 3 is shotgun, 4 is subgun. You get the point, right? And so in this file, I have the gun ID mapped to the damage, right? But we can't do something better than a map. If you look at these are in order, right? So we can actually do an array and use this to index into that array. Every time we index into an array, we just have to subtract whatever index we're using by 1 because we're starting at 1, not 0, right? So I'm going to go back up here, and then I'm going to do this. I'm going to do an std array of type int and of size, I guess, 6, right? And I'm going to call it original damages, right? And then I'm going to assign this to these, basically. So right, that should be fine. Yep, mark this as const. Now we're gonna go back down here, and we are going to do this. So we need the current gun ID in order to offset into this array, right? So let's get that. We're gonna do int cur gun ID 0, initialize it obviously, and then we're gonna do read process memory h process. Do current gun pointer plus, now where does this lie actually? So current gun pointer, that's 0, that's 4, right? So we're going to do current gun pointer plus 0x04, and then we're going to cast this to void pointer. Same thing, usual stuff, and then we're going to pass it in the current gun ID address and the size of an int and a null pointer, right? So now that we have our current gun ID, we can use it to offset into this array, right? So let's see. Let's do a one-liner. Let's do a write process memory because we want to restore that damage, right? H process. And we're going to do, again, current gun pointer. Or I guess no, we want to do gun info because we are overriding the damage, right? 010C, right? Double checking. Yep. Cast the white pointer again. Go back here. Now, we want to give it the address of this array, or I guess the element, the address of the element in this array, the desired element, right? So we're going to do this. We're going to index into the array, and we're going to do current gun ID. And since our gun IDs start from 1 and not 0, we're going to do current gun ID minus 1, right? And we're going to pass it the size of... These really should be in 16 now that I think about it, because in the game we use in 16. So these should also be in 16. Go down here, size of in 16, std in 16, and we are gonna do, what is this? And we are gonna do null pointer as per usual, right? So let's see. Let's go over everything that we just did, right? So when we enable our hack, we knob a bunch of bytes that basically knobs out those few instructions that I showed in the video, that if statement, right? So that gets knobbed out, and then we write this new value, which is our new damage. Or I guess I have a new damage here. I should just do new damage instead, right? This new damage to that memory address, right? And then once we disable our hack, we patch out the bytes again, so we restore the original bytes, and we read the current gun ID. We use that gun ID to index into our original damages, right? Now, if we run this hack, it should hopefully function. Oh, I didn't enable it from. Okay, let's just do 4, so you can see that works. It's now disabled, so if I shoot someone, I shouldn't get a one-shot kill. And I don't. Now, if I enable it, you can see the knobs are here. Back to assault cube. One shot, and one shot. Now, there's one problem with this code, and that is the current gun ID gets modified once, so it's not continuous. What you probably want to do in your own hack, since this is just a proof of concept, you probably want to find how how guns change, and hook that routine and have a callback inside your hack, right? So kind of like an event system, right? So whenever your gun changes, if the hack is enabled, you want to change the damage, right? Simple. Do this and headshot. Disable our hack, and yeah, that's it.